Hi guys, welcome to Species Clinic. And today this is actually going to be the first lecture. So welcome to SS2 first term and the much anticipated class. Okay, let's dive into this class. So today we are going to be talking about scalar and what vector what quantities. So what are we discussing in this class? That is our course outline. We are going to be talking about what scalar quantities, what do they mean? We are going to be talking about vector quantities. We talk about resultant vectors, talk about determination of resultant. So how do we determine resultant? And let's go to the class. Now, what is scalar quantity? We have talked about this in one of the classes we had for SS1. So let's dive in fully into this. So scalar quantities are those quantities that have only magnitude or numerical value but what? No direction. So when we talk about magnitude, magnitude talks about a number value. So scalar quantity, those quantities that have only magnitude but no direction. So example of scalar quantity, we have things like length, we have mass, we have volume, we have density, time, speed, temperature, energy, etc. So these quantities can only be described by their numerical value, so no direction attached to them. So scalar quantities are added by what? Ordinary algebraic method. So just add them together, just like we did in our distance. So distance is one of them. So for instance, when we say the speed of a car is what? 100 km/h, we are only provided with the what? Numerical value. We cannot tell the direction of the car. So by the time we say the speed of a car is 100 km/h, is it going to the front or going to the back, left or right? We don't know that, because that is just what is what value. Okay, let's talk about vector quantity. What is vector quantity? So vector quantity, on the other hand, are those ones that have both magnitude and what? Direction. So when we talk about vector quantity, we are talking about displacement, we are talking about velocity, we are talking about acceleration, weight, force, momentum, electric field, magnetic field, etc. Now what we are saying is this: for vector quantity there must be two things. We must have a numerical value and we must definitely have a direction. Now look at this instance here. The displacement of a bird is 100 km due east. Now from that analogy, from that instance, we see that we have a numerical value which is 100 km and we have a direction which is what? Due east. Note, vectors are always indicated with what? Arrow what? Head. Now let's talk about resultant vector. Now look at the word resultant, result of an ant. Resultant vector means what? What is the result of this vector? Now this occurs when we have two or more vectors acting together. So resultant vector is that single vector that have the same effect both in the magnitude and direction with two or more other vectors acting together. So resultant vector means what? A single vector that can replace the effect of two or more other vectors both in magnitude and what? Direction. So how do we determine resultant vector? We have various cases. Let's go to the first case. When two vectors are in the same direction, what is their resultant vector? Their resultant vector is gotten by what? Adding the two of them, because the two vectors will complement each other. Now look at this example. So we have two, we have one, both of them give us C and they'll give us an addition. Okay, now look at this example. Three boys are pushing a box along the ground. They apply the force 400, 600 and 900 Newton. What is the resultant force? Since the boys are pushing the box, so it means that all these boys are what? Doing the same work. They are trying to what? Complement the effect, the effort of each other. So what is the resultant force? So resultant force is talking about what is the total force that these boys are applying, or tell me one force that can do the same work that these boys are doing and give me the same effect both in magnitude and in direction. So how do we go about this? Since these three forces are complementing each other, so it means that the resultant force will be the addition of the three forces. So F1 plus F2 plus F3. So making the addition of these three forces is going to give us what? 1900 Newton. So and what is the direction? Because every vector must have a direction. So the direction will be what? Definitely in the direction of these forces. So let's go to the next one. So case 2. Case 2 is when two vectors are in opposite direction. Now when a vector A is opposing vector B, now what will happen is that these two vectors will what? Try to cancel the effect of each other. So how do we get this? So for this case, the resultant is going to be a negative, like a kind of differences between the bigger one and the smaller one, and it will be in the effect of what? The smaller one. Sorry, the effect of the what? Bigger one. This is like the case of what? Tug of war. A tug of war game, a man A is pulling a bus in the negative x direction, that is the direction, with a force of what? 1000 newton, and the man B is pulling it in the positive x direction with a force of what? 1300 newton. Now look at this. These two men are having a tug of war, but you should know that for this kind of situation, the person with the larger force will definitely overcome. But now how do we get the resultant force? Now look at what we have here. These two forces pulling in the opposite direction. So the resultant force is going to be what? The separation, the differences between these two forces. So F2 is bigger than F1, so it's going to be what? 1300 minus what? 1000. So the resultant force is going to be what? 300. And what is the direction? It will be in the direction of the person that have the what? Higher force, which is actually what? Man B. Now let's go to the next one. Case 3. When two vectors are what? A 90 degree to each other, how do we get the resultant vector? Now by the time it is a 90 degree to each other, we have vector A, we have vector B, both of them at 90 degree. For us to get the resultant vector there is what? Vector C. And for us to do that, you can see that that is actually what? A right angle triangle. And for every right angle triangle, to solve right angle triangle case, you make use of what? Pythagoras what? Theorem. So let's get an example on this. Work example. Example 3. Let's go. So two forces, 8 Newton and 6 Newton, acting along the vertical and horizontal axis respectively of a body. Find the resultant force. Simple. So what do? The first thing to do is to try to draw a kind of sketch of what you're talking about. So by the time you do that, you apply the Pythagoras theorem rule. So the resultant vector is going to now be the hypotenuse. So to get that hypotenuse, remember square root both sides. So it's going to be the square of what? The other forces. So F1 square, F2 square. So that's going to be square root of 8 square plus 6 square. That is going to give us 64 plus 36 computation. And that is what? Square root of 100, which is going to be what? 10 Newton. Now, by the time we are done with this, we need to get the angle, because every vector cannot survive only on what? Magnitude. We need to get the direction. So let's say that that angle, that direction is going to be what? Alpha. So alpha is going to be tan inverse of x, y all over x. So that is going to say tan inverse of 6 over 8, and we get that. So it means that this is going to give us what? 36.87 degree. So what is our answer? The resultant force is what? 10 Newton, and the direction is what? 36.87 degree to the horizontal. Let's get to the next one, case 4. So case 4 is when two vectors A and B are at angle each other. So they are at an angle to each other, but this angle this time around is not 90 degree. So how do we solve this? There are two laws to apply. Either we make use of what? The parallelogram law of vectors, or the triangle laws of vectors. So what is parallelogram law of vector? Just like the word go, parallelogram. Now by the time you draw a parallelogram, this is a parallelogram. So what does parallelogram law of vectors say? It says that if two vectors are represented in magnitude and direction by the adjacent sides of a parallelogram. Now that is the parallelogram. So that is the vector A and B. So they are being represented by the adjacent side of a parallelogram. Now the diagonal of that parallelogram is going to represent our what? Resultant vector, which will have the same effect both in magnitude and direction to the other two vectors. So now how do we solve problems on this? To solve problem on this, now the resultant, so we are going to make use of what we call the cosine rule, because if you look at that critically, you can see a triangle there. So applying cosine rule, r square is going to be what? A square plus b square minus 2ab cos 180 minus what? Theta. So but remember, based on mathematics, for the second quadrant, cos 180 minus theta is actually equals to what? Minus cos theta. And applying that, so r square is going to give us a square plus b square plus 2ab cos theta. Okay, making out the sort of formula, so square root both sides and we'll get that. So to get the direction, we apply sine rule, and applying sine rule, this is our sine rule. So from our sine rule, we look for what? The angle, and then looking for the angle, we see that alpha is actually sine inverse of what? A sine theta over. So let's get it. So let's go to triangle laws of vectors. So like the name goes, triangle. So the principle of triangle law of vectors says that if three vectors are in equilibrium, so we are going to see more of this when we get to what? The chapter of equilibrium, that is chapter 4, that is lesson 4. So they can be represented both in magnitude and direction, go back, by the three sides of what? A triangle. So this is what we are going to deal more on this when we get here. So let's get an example of this. So two forces, magnitude this and this, incline at an angle 180 to this. So calculate the resultant force if the angle makes what with this. Okay, now what we'll do is that the first thing is, okay, we'll draw this. So this is what we have there. So we are being asked to find the resultant vector or the resultant force of this. So what we're going to do is, okay, so we apply the cosine rule, which is gotten from the parallelogram law, and then put in all our values. So by the time we put in all those values, we have that what the resultant force is actually 22.34 Newton. So we look for the angle. Oh, come back. Sorry. So we look for the angles and using sine rule, and we'll get this is our what? Answer. Okay, let's go to the next example. Example 5. We have this, a mass suspended on the ceiling. So we are being asked to find the value of what? The tension. So by the time we back to this place, solution. So we represent this by the three sides of a triangle. So once we did that, so we now applied our trigonometry ratio questions. Our trigonometry ratio, that's sine cos theta is this. So we make this, so make the tension the sort of formula. When we do that, so applying that, so tension is what? 300 what? Newton. Okay, so we have gotten that. So case 5. So case 5 is when we have more than two vectors at angles to each other. So this case now is we are not just having just two vectors, we are having more vectors. So how do we do this? The best way to do this is to resolve these vectors into vertical and horizontal components. Now once we do that, so by the time we do that, so we now say that the vertical component is y, the horizontal component is x. So once we do that, we can now solve using Pythagoras theorem, because this is what is going to resolve to at the end of the day. Then solving with Pythagoras theorem, we have that r square is equals to x square plus y square, making out the sort of formula. Then after that, we look for our angle, making use of tan inverse. Then let's get the question. Now look at this, we have three vectors acting on the points simultaneously. Find the resultant vectors. Now look at these three vectors, three of them acting on the points. So what will be the result and the effect of these three forces? So let's go. So the first thing to do is to resolve this into vertical and horizontal. Look at this. So how do we solve this? So coming to the table, so we resolve the forces towards vertical and horizontal component. So if we do that, we see that the first thing is, how many forces do we have here? We have three forces, 80 Newton, 100 Newton, and 107 Newton. Now you notice that this 80 Newton is actually what? An horizontal force. So, and that will say that the angle is what? 0. So 80 cos 0 is going to give us what? 80 under the horizontal component. So since it's an horizontal force, it means that it has no vertical component, making its vertical component to be what? 0. Now look at 100. 100 is an inclined force, but take note, this 100 is what? In the what? Negative x direction and what? Negative y direction. So that is why you see now for the x direction, which is horizontal component, you see that it has a negative sign because this is pointing towards the what negative x direction. So that is what minus 100 cos this angle 60 degrees, so that gives us what minus 15. Now for the vertical component, if this is also pointing in the negative y direction, which is this direction, and that's why it has minus 100 sine what 60, so this gives us this. Now for the last force, this is what a vertical force is pointing in the what positive y direction, so that is why we have 107 cos 90 degree, so that gives us 0 because it has no horizontal component and this is a vertical component. So adding this force, the sum of this minus this plus this gives us 30, while this minus this plus this gives us 20. So by the time we have done this, so using Pythagoras theorem, so we have 20 square plus 30 square, square root of this, so that will give us the next thing to talk about. So it means that r is equal to what? Root 1300. So by mathematics, that's going to give us what? 36 point what? 36.1 Newton. So we look for the angle making use of trig ratio of tan inverse, and that gives us this. So this is going to be what? Our resultant what force. So let's get to the next question. Work example. Calculate the magnitude and direction of this resultant force. So we have how many forces here? So these forces, so we now resolve these forces into vertical and horizontal components by listing out the angles we have for each of them, and then we solve it. So you can see the same way we went through the other time is what we are also going to do for this time around. So by the time we do that, we resolve them into vertical and horizontal components. So after that, we find the resultant force. Then after getting the resultant force, we get the direction and direction of the resultant force. So after that, we identify my god. So looking at the direction of the resultant force, this. So theta is negative, so tan theta is negative in the second quadrant and fourth quadrant. So these are just mathematical trigonometry knowledge that you need to have. So theta is equals to this. So at the end of the day, we have gotten our angle. So thank you very much for following us for this class. So these are questions that you can look into and try solving them yourself. So thank you very much for listening. So see you in the next class.